Thank you for joining our presentation on surface finishing for trauma and spinal implants. Our speakers are Bernie Kirschbaum and Brett Eldridge of Rosler Metal Finishing USA. Bernie serves as CEO and Brett is Product Manager of Mass Finishing. Surface finishing techniques play a key role in the quality, performance, and lifespan of orthopedic implants. For over 40 years, Rosler's products have been setting new technical standards in surface preparation and surface finishing. Rosler offers the widest range of surface finishing equipment in the industry, including mass finishing and shot blasting technology, grinding and polishing media, and compounds for mass finishing.
Welcome and thank you for watching. My name is Bernie Kirschbaum. I'm the CEO of Rosler Metal Finishing.
And I'm Brett Eldridge. I'm the product manager for mass finishing equipment.
We're sharing some insights on finishing of trauma and spinal implants. Finishing is an essential process in the production of medical parts. A part is not finished until it's surface finished. Yet, in most cases, there are multiple finishing steps along the production process before we even get to the final product. We break this into in-process finishing, like descaling, deburring, and powder removal.
And for final surface finishing. This is what the customers, doctors, and sometimes the patients see as the finished product. They can have different appearances and requirements. Some of those are functional and others are more cosmetic or both. Smoothing of the surface is for cleaning and sterilization. Polished surface is to prevent osseointegration. Shot peened surface is to improve tensile and bending strength. A roughened surface is to promote osseointegration, and a matte finish is to reduce glare on the part.
Brett, what information do you need from the trauma and spinal implant manufacturers to determine the best process? What keeps them up at night related to finishing?
Functional requirements is a big key to figuring out what's best for them. One of those requirements would be osseointegration. Does it need to be low or high? And that would require either a smooth or a rough finish. We'd also want to know what materials are being used. Is it a metal, a plastic, or ceramic, or some type of coating on the surface? We also want to talk about processing cost. Mass finishing parts is typically a lower cost than adding a CNC step in to achieve the same type of finish that mass finishing can do.
And other aspects we take into consideration are related to manpower, operator skills, and the manufacturing methods itself that's involved in the overall process. The product-specific requirements often relate to around biocompatibility, osseointegration, the gliding characteristics. So, for example, if the tendons must go over an implant, or the strength and fatigue life of the implant itself. These requirements drive the finishing targets listed in the right column. And this can be anywhere from smooth and polished to burn stress-free. And that's why it's important to get the finishing experts involved to find out how we get there. Brett, when you use which method? There's so many. What do you pick? And can you explain the main methods briefly?
For mass finishing, we are typically looking at deburring, creating smooth or a polished finish. We can achieve any of those types of finishing through vibratory bowls or troughs, high energy or centrifugal disc machines, and drag finishing as well for high value parts. With all of these machines, we use abrasive media with a cleaning compound, and those rub against the part to achieve the surface finish.
And the other process is blasting. Here we distinguish between dry and wet blasting. The dry blasting can be done either with a wheel or with air blast systems, and they create either a matte or rough finish depending on the material we use, whether it's shot or grit. Shot usually gives us a matte finish, and grit, which is a more angular shot media, provides the rough surface. And we also can achieve different finishes by using different materials like glass beads, ceramic blasting media, stainless steel, or even plastic. Wet blasting uses a water-based slurry that typically creates smooth and matte finishes. And sometimes you even have multiple blasting processes throughout your production. It could be early in the stage to remove some scale, or later in the stage then to obviously achieve the final finish. And the three graphics here, top left is the shot, more or less a round shot to give a matte finish. The angular Grit is obviously more aggressive, leaving a rougher surface finish, and then the slurry-based water system at the bottom, again with different medias, can sometimes achieve actually surface smoothing as well then as the matte finish. And Brett, what's shot peening?
Shot peening is a specialized blasting process that creates compressive stresses on the part surface and therefore ensures better fatigue life or tensile strength.
Here's a short video that shows the different processes in action. Let's have a look at the video.
So here we have a vibratory bowl with plastic abrasive media. Vibratory bowls tumble around the circumference of the processing channel, and the vibratory action will provide deburring, surface finishing, and polishing depending on what type of abrasive media is being used.
And you can see the parts are in here loose.
Here we have a high energy disc finisher or centrifugal disc finisher. You can see the 8 to 10 times more of the energy. And here is a drag finisher where the parts are fixtured. As you can see our operator here. Typically for a higher value part, you have your rotating carousel with individual workstations dragging the component through the abrasive media.
And here also we have the option to use multiple medias to achieve obviously a progressively smoother finish and up to a high gloss polishing. And this is a wet blasting process. You can see the water slurry, the abrasive slurry hitting the part. In this case, it's fixtured to a turntable, and we're blasting it to achieve the smooth finish. And at the end, the part is being rinsed off. Is another example, and it's ready to go. Brett, let's talk about a few examples of finishing solutions.
So what we have here is we're looking at some bone plates and medical instruments. These are typically larger or longer parts, and we will run these in larger size machines such as vibratory bowls or troughs. We can achieve deburring and final polishing. This is to get to the final polish. It can be a multi-step process, which would include the Rosler Caramo finish process. Here with the bone plates, we have about a 6-hour process with ceramic media to deburr the parts, and we can do a high quantity at a single time. With the scissors example, where we're using a ceramic media to cut down the parts, and the customer wanted a polished part, so we run our Caramo finish polishing process for approximately 10 hours. Sometimes we just deburr the instruments as they may be blasted as the final product, so there's a non-glare finish.
This example is for a low volume part. Here we've got some long bone nails. The number of parts and the shape is ideal for finishing in a vibratory tub. Sometimes it requires masking or plugging the holes to prevent media from lodging in it. Other than that, the process doesn't really need a lot of operator involvement. So we're loading the parts, we're letting the process run, and we'll basically have to take the parts back out. In this example, we've actually got a 3-step process with a cut down with ceramic media, a pre-polish with plastic media, and then again the Caramo finish polishing process that uses non-abrasive ceramic media and a grinding paste to achieve a constantly smoother finish until we really have the high gloss polish. In this example, we were doing about 15 parts per hour. This can be done in a single machine if the parts volume is really low, and we are changing the media out at that point in time. Or we can have one machine for each production step. Obviously, that would eliminate the media exchange in this case.
Here's an example for use of a high energy disc machine. We're looking at pedicle screws and bone screws, which need to be deburred on the threads. In the process, we can do a high quantity because of the size of the parts. With the high energy disc finishing, this is 8 to 10 times faster than a typical vibratory bowl. So it increases the output for the customer. With the 2-hour process, they get 400 pieces in there. As you can see in the picture, we fully unload the media and parts so we can guarantee a batch-to-batch integrity for the parts. Another great example is a 3D printed part, which has a very rough surface after support removal. Through a multi-step process, we use different ceramic media to achieve the smooth finish for the implant. We typically will run 2 to 4 parts per hour with changing out the media. Again, you could have multiple machines, so you didn't have to change out the media as well.
Here's an example of an in-process finishing solution. This will happen typically early in the manufacturing process, where we're removing the scale and maybe some shell from the forgings, castings, or heat-treated parts. This can be done in a wheel, air blasting, or wet blasting system, and a lot of times that depends on the requirements that we have for the parts and the parts volume. In this example, this was an automated, semi-automatic blast system, which a small air blast cabinet with a basket that can run about 350 parts per hour. Cycle times for these sort of things are in the sort of the 10-15 minute time. So again, multiple batches per hour would achieve that 350 parts. If the volume gets really large, then we could go with a different machine, and maybe a wheel blast system might be more efficient. The wet blasting also is a good opportunity there to remove final shell from an investment castings before the parts go into the next process.
Here's our example of our shot peening. Again, as we stated, it's a very targeted blasting process. Depending on the parts, fixturing or masking may be involved, so we only hit specific areas. For these titanium bone screws shown here, we were focusing in on the threads of the parts, air blasting with a steel media on a satellite table machine. So they were able to achieve 300 to 350 pieces per hour. Also, you could do spinal rods, which are longer rod material, which could be automatically fed through a cabinet on a roller feed system. So you can continuously blast the rod on a constant basis for some high production.
Here's some of the examples of the full range of equipment. On the top row, you see different types of vibratory finishing, a bowl and a tub, and they come in all different shapes and sizes. In the middle, we see a high-energy disc machine, actually in the unloading position. The round portion there is actually the processing bowl that where the parts are finished, and then the square attachment there is our media separator, so we can get the media and the parts separated. And on the right-hand side, you see a drag finisher where the parts actually are fixtured and then dragged through the media itself. The bottom row there is an air blast system, a wet blast system, and a shot peening system. Again, mostly revolve around how to get the media through a nozzle and target it at certain parts of the part or into a tumbling mass of parts. So Brett, how do you pick the right system and the size of machine that we recommend?
Well, what we look at, we definitely have to look at the part size and the customer's production volume. Another key aspect would be to run processing trials. There's a lot of other factors that go into it, but that's why it's so important to get the finishing experts involved to find the best solution.
If you'd like to learn more about the finishing of trauma and spine implants, please request a copy of our surface finishing guidebooks. They're also available on the Rosler blog for download. And the Rosler blog also has a lot of other valuable information that you can check out. Just search for trauma, spine, or medical on the blog, and you'll get a wealth of information there as well. So thank you, Brett, for your insight, and thanks for watching.
Thank you to Bernie and Brett, and thanks to those watching. To learn more about Rosler Metal Finishing USA, visit us.rosler. You can access more content on orthopedic manufacturing, trends, and innovation at omtechexpo.com.